Not completely finished, but finished mostly. Jake, get off my computer cables. Jesus Christ. Here, come here. Come here. Come here. That's fine. Nah, here. Here, come here. Of the third iteration of my atmosphere shader, it's pretty fucking cool. I'm pretty happy with it. We've got shadowing through the atmosphere via the clouds. So last night I fixed the quality and performance up to my satisfaction. So we had issues with like some slicing appearing and some kind of jankiness in the clouds, a lot of blue noise showing through and things like that. And it's really a challenge to make this work because you need a lot of slices in the clouds. You don't need a ton of slices in the atmosphere, but it all has to happen in the same pass. So we have adaptive sampling for clouds and atmosphere, but that alone wasn't enough to fully optimize this. But what I did last night was I added in to our ray marching parameters a step scale factor. And what this does is it prioritizes step density at the start of the ray. So your over the course of the ray, you will go from whatever your base step size is to progressively larger and larger step sizes as it gets further away from the start of the ray, which would correspond to either the distance from the camera if you're inside the atmosphere, or the distance to the shell of the atmosphere, or the distance from the start of the shell of the atmosphere if you're outside the atmosphere. And with that, we now are running pretty performantly. I'm getting, 60, 70 FPS when we were down to around, honestly, with these settings, it would have been chugging at like 5 FPS for the adaptive sampling. So, we want to work with this procedurally. One of the challenge I had with the former version of it is that it had a lot of hard-coded sizes. But we really only know the planet size very effectively at spawn time. I mean, without a bunch of calculations. So what we want to do is basically we want to make everything scaled relative to the planet radius. And I think we can do that entirely within the material itself. I don't think we have to make any shader changes. So, for example, we have these radii here. So, we could say this would be times 1.3. Yeah, so we'll... I'm trying to think if we need to change the names of these, because this would go down to like 1.3 times the planet radius, point blah 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 times the delta between those two, this kind of stuff. So let me think about this. So with our current params, this would be about 1.3 times this, roughly 1.33. So we'll rename this to atmosphere height scale, set it to 1.3 repeating, and then multiply it here, and that should be roughly the same. And then we can say minus, this gives us our atmosphere thickness. I'm wondering if this should be 1.33 or just 0.33 and we add 1. Let's do 0.33 plus 1. that, and then uh, cloud inner height scale. And these will turn to, let's say, point. Wait, what was the former value? 165. So that's like, we'll just say point 0.5 and point 0.3 for now. And then what we'll do, so take each of these, multiply them by our total atmosphere thickness, and then add. Jake, would you get off my cable? Get off my cable. Okay, there we go. So you add here, add that to the planet radius, and then finally we can plug the results of that like this. I think that makes sense. So now we only have one hard-coded planet radius. We may also want an offset here. Sphere, floor, offset. Atmosphere, floor, offset. And we'll call this like 0.0001 or something like that. And then we can subtract, grab all of these guys, put them in here, re-rig this, this. Okay, and this is going to give us a little thing that we can tweak the floor of where our atmosphere starts. So I think that should do it. Oh, God. Oh no, it's gigantic. Alright, let's figure out what we did wrong. So, this is our new planet radius after being adjusted. Oh, I know exactly what's wrong. We need to restore defaults. There we go. Okay, we're back in business. So now everything should be relative. So if we were to say, we want to be able to just like have a consistent atmosphere regardless of how big we make the planet. That looks pretty consistent to me. And then let's select the sphere at the center of this and make it the same size. All right, now we can look at what our baseline looks like here. Okay, and all right. So if I bump this up, you see how I can move the horizon down a smidge? Because like the bottom of our raylet, we don't really want it directly at our surface level, but we also want it to be like percentage based control so that it's not like this is a lot better because now we have the sun on the horizon instead of like disappearing before the horizon. All right, excellent. So that means everything is now contingent. The only real world scale we're providing is the scale of our planet, which is how we want it to work. And we're kind of hunting default values for all this stuff to use. Yeah, what up, dude? Yeah, so this is the third iteration. This one, I had an epiphany a little while back that I kept trying to do like clouds separately, um, but it's all scattering. The way the atmosphere looks is based on physical scattering, and the way clouds look is also based on physical scattering. They're different types of scattering, but they're still based on scattering. And I realized that I needed everything to march in one pass. Um, and the reason for that is because as that light travels through the substrate of the atmosphere and the clouds, things are happening to that light that affect subsequent steps down the chain from it. So, for example, light goes through a cloud, the light coming out of the bottom of the cloud is darker than the light coming into the top of the cloud. And it's not just darker, like, it's not just the bottom of the cloud is darker. It's like, not only is the bottom of the cloud darker, but there's a shadow. Everything under it is darker. So this is my seems to be mostly successful at this point attempt to basically simulate that entire process. So you can see now we have shadows from the clouds like streaking through the atmosphere. And when you do it like this, you get natural effects that look really nice. We get like God rays. Actually, let's really exaggerate that. So I'll bump up absorption to make the clouds darker, like a lot darker. There we go. And now you can see that we have the clouds casting shadows through the atmosphere and down onto the planet. And now this is more absorption than you would want to run with. Obviously, we're getting some like kind of banding and stuff that I will eventually try to hunt down. It's because I introduced adaptive sampling. So the samples further away have larger step sizes than the samples close by. So like the clouds up close to us look good. In the distance, it looks a little jank. But that's really just because we have an absurd value for extinction here. If we get rid of that, you can still kind of see the variance in the light coming through the clouds. They cast shadows on the atmosphere itself. So like if I come out here, we can see the clouds casting shadows on the atmosphere. Everything is now, what I just did is I just took out the last non-relative measurements with the exception of planet radius. So the only thing we have to know is planet radius. And if we increase the planet radius, the overall effect should remain the same, just at a larger scale. And that'll make it easier to proceduralize. What else? What else? What else? Oh, yeah, yeah. The other cool thing is we have scattering parameters for every single. We have scattering parameters for every single type of scattering we're doing. So we have absorption coefficients for the atmosphere, ambient coefficients for the atmosphere. This is how much light you get on the dark side of the planet. So like if I go down to the surface here, I don't know how well it comes through, but you can kind of see like a blue haze around the horizon. Would you guys chill out? Chill, puppies. Um, yeah, so that's controlling like the ambient side of the planet. If I was to take this and like increase the value to like 0.6, you would see a lot more. We don't need that much though. Can you guys chill out and get off of me while you're tussling? Hey, no. These puppies are driving me crazy. Okay. We have the coefficients for Raleigh and Mie, and all of the coefficient, no scalars, it's all vectors. So, for example, let's say we wanted the atmosphere to have different Raleigh scattering. We can just do that, and all the colors in every other part of the shader will update accordingly. Like the clouds are going to get the pink tint now. Everything is unified. So we'll go back to about what it was before. Likewise, Mie, that's like the sun scattering at horizon level. So like this kind of blur. So yeah, if I change the Mie scattering, then our horizon scattering changes. We also have cloud ambient. Same thing as the atmosphere ambient on this side. If I say bump this up to like 0.5, it's way too much. 0.1. This is like the darkest the clouds can get, basically. What was it on? 0.05, 0.03. I'm just going to cancel it. Stop. 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 You guys are stressing me out. I mean, they're just playing. It just sounds like bloody murder when they play together. We also have some really cool stuff. So the absorption through the clouds, we can control individual colors that it absorbs. So like for example, what if we absorbed 10 times more green light than red and blue light? Well, now all the light that's actually making it through the clouds is a combination of red and blue because most of the green got absorbed out. But if we're in the clear sky, the light reaching us is blue. So like we can control the type of light that's absorbed by the clouds, which controls like the underside of their shading. We'll go ahead and cancel that. And we can also control the actual cloud scattering itself of the light bouncing off the clouds. This controls like the top side. So yeah, it's got a lot of like little fiddly parameters in here. Then we have our ray march. So like I said, I introduced adaptive sampling, which means that the clouds up close to us are getting way more steps than the clouds far away. That's controlled by this step scale factor here. These steps are no longer deterministic like they were, but I've been actually like kind of fiddling around with these values to find something that's like reasonably performant. What else is cool in here? Oh yeah. This also takes into account the light color as an input. So, for example, we have a light direction vector. We can change the direction that the light is shining on the planet from, or like if I go up above it, it's a little bit easier to see. So we can control like where our light is coming from, and then likewise, we can control the color composition of our light. Like if I wanted to tint the star yellow, I could go this way. And our atmosphere is still reflecting, scattering blue, but now it's kind of greenish because we've gone to like a yellow light input, or pink goes to kind of a purplish color. Blue just goes more blue. But yeah, this is pretty cool. I'm pretty happy with it so far. It's performant, it's modular, it's I think has just about the bare minimum number of parameters that it would take to actually accomplish this, which is good for proceduralization. The other shader was way more complex than this one, but not as advanced. It's like the end code for this shader is right here. It's all in this custom node right here. If I look at VS Code, pull that up, we've got 335 lines of code to do that. I'm going to publish this at some point on my GitHub, but I haven't completely finished it yet. But yeah, so another thing we do is before we do a march, instead of just having a marching loop that just does the thing, we actually plan the march. So what that basically is we have a structure that looks kind of conceptually like I'm not I'm not gonna get it perfect, but we have a structure that looks kind of conceptually like this with uh, this as the planet, this as the inner atmosphere layer, this is the outer layer, and this is the cloud layer. So we want more samples inside the cloud layer, and we don't need as many samples. Let's go to black. We don't need as many samples inside the atmosphere layer. So what we do before we do the march is we compose a set of line segments for a given ray. Let's say this ray. I'm doing this because this is the maximum number of segments we could have. We pass through the outer atmosphere shell, through the cloud shell, through the inner shell, back through the cloud shell, back through the outer atmosphere shell. So this would be 5 line segments. We have a segment here, we have a segment here, 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 and here. 1, 2, 3, 4, 5. So that's the most we could have. And what it'll do is it has a base step size. So let's say your base atmosphere step size is 1. No. Let's say your base atmosphere step size is 4. And your cloud atmosphere step size is 1. It means when you march this, you're going to get 4 times as many steps. But that's just the base size. We have another function that basically determines the start of the ray, and it increases the step size as the distance along our plan increases. So as we march further along our plan, our steps get more and more spaced out, which gives us a huge performance upgrade without a ton of quality loss. We actually get a quality gain because we can have more steps because our we're not using all the steps anymore because our steps are getting bigger as they get further away. So that means that up close, the clouds look pretty smooth and consistent. And then in the distance, which is easier to see from outside of the planet actually, in the distance, they start to get a little bit more choppy, a little bit less defined. But always when you're like flying through a cloud, you should have pretty good quality. And so part of the reason this looks a little weird is that we just have a black sphere inside of this. I don't have an actual planet, so all of these shadows are just falling on a black sphere instead of on like the actual scenery of a planet. What else? Oh yeah. My other shader, I never was able to get it to do full occlusion correctly to the point where like if a luminous object was outside of it, then that object would show through the atmosphere. So like on the dark, this is really obvious on the dark side of the planet because you would see the edges of the clouds and then you would see the stars shining through the body of the clouds. But we have that fixed now. So let's just go and I haven't fully parameterized the cloud density sampling because there's still work I want to do here. But it's good enough to test and verify that all the like scattering and such is working. So let's make this a lot denser. All right, so sun's a luminous object, but as it goes behind the fully extinct parts of the clouds, it's actually obscured, which it would not do that before. It would just shine right through everything. Likewise, if we cruise around under the like full cloud cover, if the sun's behind a cloud like it is here, you can't actually see the sun. You just see a little bit of the glow reflected in the cloud. But if I go to a gap somewhere, although I made it too dense, now I can't find a gap. Now you can see the sun. Or a sunset, for example, over here. You can see the clouds obscuring it. As it approaches the horizon, it's going behind some clouds and it's almost completely obscured, and now it's gone. So yeah, this is a lot more advanced than the other one as far as like the logic of what's actually happening is much closer to the way it actually works in physics. Um, Actually, let's play around with some of the scattering from inside of it. I need to find some good default parameters to like try to replicate like an Earth-like atmosphere, and then I would kind of branch off on that and randomize those to make it more varied, and then we would build a proceduralization harness around it, and we would be good. So yeah, I'm going to integrate this into the planet stuff. I really want. So the I finished the large scale, the like above star system scale piece of the like goal. I can let's save this. Let's just open the other projects. And I'm preparing for the time when I merge the two together. So now I'm kind of focused on like polishing up the planet logic because the next thing that I have to do, the next large step, is to basically merge the very large scale stuff with the planet level stuff so that instead of spawning placeholder spheres, I'm spawning actual planets. And to see that, we can open this. But this part of it is pretty much done. Like there again, any of this could have a deep dive on it, and you could spend like weeks just polishing up a single point of it, like getting it optimized as possible. Um, there's definitely still stuff that I could do in the large scale project that I will have to do, but it's good enough to basically demo what I'm talking about. But yeah, I'm pretty happy with this atmosphere shader. This has been like, I think I started it last Thursday, but I've done this rodeo 3 times now. The first time I just made an atmosphere shader. The second time I made an atmosphere and cloud shader, but they were on a separate march. So there was some weirdness with it where it doesn't behave completely perfectly. And then this time it's a fully unified march. It does all the scattering in one pass. The scattering and absorption from any step will affect the subsequent steps. So, like if light is absorbed by a cloud, you saw it was casting like God rays and things like that. Um, I was also thinking I would probably make the direct because like it's always a challenge with the planet. You need a directional light, but like you can't light an entire solar system with a single directional light. But I think what I'll do is integrate the directional light for the planet into the atmosphere blueprint, because we already have to define a light color value that also includes intensity, because it's not a one, it's like a whatever scale you want. Like right now I think I have like 888, which could be translated probably to the light intensity of your directional light and the color of it. And we also have to provide a light direction. So if we have to provide those things to the atmosphere shader, we might as well let it, or the atmosphere blueprint, we might as well let it also direct the directional light for the planet. Okay, so this is my very large scale thing. This is our universe. I'm just going to increase our speed by a lot, and we'll go out and take a peek at what our universe looks like from afar. So this is our universe of galaxies here. And I'm just going to go in here, and we'll go to a galaxy. How about this one? Where'd it go? Oh, great. It never works when you're trying to demo something. There it is. I do have to do some work on the fade out ranges and spawn ranges. They're not mapping as closely as they used to. So here we got a nice little just disk galaxy. I don't think this is a spiral. No, it is a spiral. We do our own little custom volumetric here. And then I could fly to any one of these stars in the galaxy. Let's take this one. And again, I have some issues with the spawn ranges right now. And we spawn a little star system. And this is what I mean by like you could deep dive on any piece of this. This is just like me slapping together like some orbit based spawning and stuff, but I did not do like any major effort to make this like a realistic star system spawning pattern. And then finally, so this is all in virtual coordinate space, and finally we'll get down to the the object within the star system level, and that's going to spawn into actual world space. Although again, my spawn distances and material aren't quite right. So for example, say this was a planet that we were zooming towards within a star system. And hopefully it'll spawn. And hopefully I haven't swept past it. I did sweep past it. Let's go back. Okay, you know what? Let's find a bigger point. There's one. It does make it kind of difficult until I get the fade out of the particle to match the spawn trigger. It's not. It's like a day of work probably to hash all that out. But here we go. Okay, heading towards this guy. Looks like this is a planet with some moons. All right, and as we get close, we spawn these objects, and I don't know what's happening there, but these are all in world space. So these are no longer in virtual coordinates, although the particles here are freaking out. I don't know what's going on there, but these are in actual world space. So these would be their actual sizes of whatever object they spawned in for. I don't know how big these are. We might be able to figure out though. Hang on. Okay, let's see. 1, 2, 3, 4, 5. So this would be like 149,000 kilometers. So this would be like a Jupiter-sized planet. Um, yeah. And the fact that this is moving is because we're still in parallax. if I, for example, select the universe actor, there's a speed scale there, and the speed scale is right here, and this affects how much uh, faster we're going than like world speed in relativistic units. So if I scroll this down to 1 and I move, now I'm moving in real space. And these, since these objects are at unit scale of 1, they would be stationary. They would basically we would short circuit the parallax logic for like the planet actor when speed scale is 1, so that you can actually fly and move around on the planet without having the whole planet constantly in motion. It would also control things like we wouldn't want to be doing LOD calculations while you're traveling above warp speed, right? Like while you're traveling above 1. If you're above 1, you're basically traveling at like interplanetary, interstellar, intergalactic speeds. So again, on my mouse wheel, when I wheel up, it's times 2. So this would be for every centimeter we would travel, we're traveling 419,430. No, wait, 4,194,304 centimeters. So every centimeter I travel in real space, all every other thing in here is going to act like it's moving 4 million centimeters. And that would be good enough for traveling like within a single star system. But to go interstellar, we have to be substantially faster than that. And to go intergalactic, we have to be substantially faster than that. So the idea here is that instead of loading orange balls at that bottom level at the real world scale, we would first of all optimize our planet to be able to be spawned in real time, which means we spawn. It's going to be like a loading process. Like we load a low level of detail, we load the atmosphere in, and then when they stop moving at relativistic speeds, we would then uh, turn on like LOD for the planet so that it can actually start generating new meshes when you get close to it and things like that. Ooh, that's a nice spiral there. A neat spiral galaxy. But yeah, so the next step is basically I need to polish up the planet, get it to where it loads well, it's loading quickly, um, it's performant, it's stable, uh, which the atmosphere refactor I was doing is part of that. I wasn't satisfied with the one that I had. Um, I need to hook the planet up to a parallax actor so that it can get parallax. I need to add some logic in there that toggles between like load the LOD, like actually do LOD mode and not. And then I need to start spawning it when you get close enough to a planet type object within a star system, which let's find another one. I'll go to this one. Maybe. Yeah, but the first thing I need to do in this project is actually fix my screen space thresholds for spawning things and fading out the correspondent. Where'd it go? I saw it load in. Because it makes it really fucking hard to find shit. There it was. What the fuck? Can I load a star system, please? There we go. Now we got a star system. Oh, looks like we got a close by planet here. Oh no, that was the star. Okay, well, you get the idea. Still a ton of work I could do on making the star systems accurately generated the same way I spent time making the galaxies more accurately generated. Ton of work to do there. Uh, just like I said, you could pick any small facet of this and sink months of work into it. But I'm just trying to get like a bare minimum stood up and then move on because I'm just one dude, you know, like it takes a while. So going back over here, I was kind of working on cleaning up this material, getting it configured properly. But I'm actually about to have to walk these puppies, so I'm not gonna be on here too much longer. Hey Jake, hey Ted, do not start. Do not start pestering him. You're gonna be annoying and fight on top of my body, and I don't want that. We should probably integrate this into the other stage that has the actual planet. That would be a good next step after I get the material cleaned up all the way. I mean, it needs a blueprint. Like the whole atmosphere should have a blueprint because we need to have like a placeable actor, not just a post process material. We'll have an actor. It'll contain a directional light and a post process volume, and it will expose all the material parameters so that you can dynamically adjust them on the actor. And then we should be able to integrate that into our planet stuff. So let's go back to the material. Why did you do that? Why did you not come? I think I dragged it and it didn't come along for the ride. It's supposed to. Okay, cloud and atmosphere scattering parameters here. Ray march steps. We'll put that down here. Don't really care too much about the ray march steps. Once we come up, once we like kind of land on a good optimized setup for this, it doesn't really matter. Then we've got our light parameters. That can go here with the scattering equations. That makes sense to me. Position and scale can be grouped together. That also makes sense to me. And I just want to get all of this spaghetti in the same comment container here. Jake, I swear to God, you're driving me fucking crazy. This is going to have more parameters because we're going to need to be able to control like the cloud noise and stuff eventually. Right now it's just all hard coded. And I've just been futzing with it um, in the code itself. Stop. Oh my god, this puppy is driving me insane. Stop. You little turd. Oh, this one. Don't like that very much. Alright, that should at least be a little bit neater. Maybe the Ray March step should go up here. But this stuff you don't really have to deal with meddle around with that much. This stuff are the parameters that actually do the heavy lifting. I mean, we're just moving spaghetti around at this point, but feel like that's pretty neat. We're gonna have a few more parameters here to control the cloud noise, which I will probably do a whole session just to find the best way to sample the cloud density. Right now I just have some stuff I threw together in there. But yeah, I don't know how much else there is left to do on the material. It seems to be pretty much functional the way I want it to work. Um, yeah, I'm gonna go walk these dogs because they're freaking out. So later.